Hello, today we're going to talk about relations and functions. So let's look at some important vocabulary before we begin some examples. So, a relation is nothing but a set of points. So that is a combination or a list of points, whether it is in a table, a mapping diagram, or a list of points listed out separated by commas. A function, however, is a relation, which is a set of points that do not share x values, meaning that your x values cannot repeat. For every x value, there is only one y value. Okay, so let's look at example A. It says determine if the relations below are functions. So for example 1A, we are looking for the x values to repeat if it's not a function. My x values, these x values do not repeat. All right, so I can say that yes, this is a function. If I look at this mapping diagram, what may help me is if I were to make an actual table of this information. So if I were to make a table of this information, I'm going to have my x's, I'm going to have my y's. As we can see, the -5 as the x value goes with 6, which is the y value. The -2 goes with the 3. I can see that -1, it goes to the y value of -1, but it also goes to the +9. And then we have the 4, which goes to the 6. All right. So remember, the rule of a function is that your x values cannot repeat. So if my x values repeat, I know this is not a function. And as you can see here, I have these two x values that repeat. So my answer here is no. So this is not a function. Okay. So now let's look at a test. So the algebraic test to figure out if something is a function or not is that you are going to substitute in a value for x and solve the equation for y. If it is a function, it will only produce one y value for that x value. Okay. If you draw a vertical line and it intersects the graph more than once, the relation is not a function. So it depends on whether I give you a graph or whether I give you an equation. Okay, how you could tell. So if we look at the graphical features, okay, it says if a graph has an open circle, that point is not included. If a graph has a closed circle, that point is included. If the graph has an end with an arrow, then the graph continues forever in that direction or pattern. So now let's look at some examples. So example number 2 says, determine if the equations below are functions. So remember what it says. Remember, you cannot have x values that repeat, meaning that if I plug in an x value, I should only get back out one y value. So let's use, for example, 2a. So it says y is equal to 7x minus 4. So I'm going to choose a random x value. It does not matter what number you choose. So let's say that x is equal to, let's say that we want x to be equal to 2. So if I substitute that in, that's going to be y is equal to 7 times 2 minus 4. And when I simplify that, I will end up getting 14 minus 4, which is 10. So as you can see, when x is equal to 2, y is only equal to 10. So I can tell here that there is only one y value for that x value, which means that this is a function. This is a function. All right. Now, if we look at B, let's choose a random y value. It does not matter. So let's choose x is equal to 9. So when I plug that in, that is going to be 9 equals y squared. Remember, I am substituting in for x. So we should know that the opposite of squaring is to take the square root. Now, the definition of a square root is what times itself gives you that number. So if I say the square root of 9, I'm asking myself, what times itself gives you a positive 9? So we can have a positive 3 or we can have a negative 3, because negative 3 times negative 3 is also a positive 9. So here I can say that y is either equal to a positive 3 or a negative 3. Remember, I can only have one y value, and this one would technically have 2. So this one would not be a function, because the 2 points that will represent this would be 9, 3, and 9, negative 3. All right. So now let's look at example 3. These are graphical representations. So remember, if your vertical line cuts through more than once, then it is not a function. So I'm going to make myself a vertical line, and I'm literally going to take this vertical line and I'm going to move it from left to right. This only hits this once. It only hits this once. And let me zoom in. If I go over, it only hits this graph once, only hits this once, and only hits this once. So here I can say that this one is a function. If I go to B and I literally move it over, I hit more than one space. So as you can see here, I hit here, 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 and here, and here. So it hits more than one point. So I know that it cannot be a function. All right, so this one is no. All right, now let's look at C. If I were to take my graph, it should only touch it once. So as you can see, I'm only touching the spaces once. All right, so I get here. I am going through a solid and a open circle, a closed circle and an open circle. Remember, a closed circle means that I'm included. An open circle means that I am not included. So here I can say it only touches the graph once, because this open, remember, this open circle is not included. So it's like it doesn't count. If it goes through two closed circles, then it's not a function. If I keep scrolling, same thing here. My closed circle is on top, the open circle is on the bottom. This is still a function because it's not two closed circles. And then if I keep going, it only touches that line once. Okay? So this one is a function. Okay, this one is a function. So now let's look at graph D, the same thing, taking from left to right. It's only hitting one time each time. So as you can see, this last graph is actually a function as well. All right. So literally that's all you do. If you want to, if you don't want to have to keep drawing a whole bunch of vertical lines, you can use your pencil or your pen and just put it straight up and down and just scan it like I did with that line from left to right. All right. If you have any questions on relations and functions, please let your teacher know, and have a great day.